Ralpalli, tell me about yourself.
Hello, sir. My name is Ralpalli Lakshman Rao. I'm from Visakhapatnam, Andhra Pradesh. I have done my graduation in 2021 in EC branch with a grade of 7.12, and I have joined in Capgemini as manual testing, and I have done my training in PD while I'm working in Capgemini itself, and currently I'm looking for job in VLSI domain, that in PD.
First thing is, Ralpalli, relax. I think you're completely stressed out. Relax. Take your time. Don't be. It's like let it be a friendly interview. I'm not interrogating. I'm interviewing. So be cool. Don't worry if you are not able to answer anything. That's fine. But be confident. Be relaxed. Okay. Be relaxed. Don't assume that I'll be asking tougher questions and all. Just be relaxed. Okay. Be confident. Fine. Tell me, where did you do your PD training?
In VLSI Guru Institutions, Bengaluru, sir.
Okay, fine. And what was your final year project in BE?
Yeah, it is. I have done many projects, sir, but main project is what is smarter surveillance system, sir.
Surveillance system. So, what is the domain that you worked in making your project?
Yeah, it's embedded.
Embedded. Okay. Fine.
Yeah.
So now you are in Capgemini working at right now. Right now you are working, right?
No, sir. I have resigned. I have resigned on 9th December.
Right.
I'm fully focused in VLSI only.
Okay. Why you thought of working in VLSI? What made you to get into VLSI?
Yeah, actually, I am from diploma, sir.
Okay.
Since diploma only, I wanted to work in VLSI because I like that VHDL, VLSI, but later on I couldn't able to do my training because of my family situation. So I thought to do my job, and while doing the job, I will earn some, some amount. But with that amount, I plan to do this course.
Okay.
So with the same plan I have done, and I have done with my training. That's why I left the job.
Okay. Then now you are trained in PD, right?
Yes, sir.
Okay. Fine. What are the subjects you are good at when it comes to electronics?
Basics of digital electronics, basics of STA, basics of synthesis, and PD, physical design.
Very good. So we'll start with some digital.
Okay, sir.
Okay. Fine.
Yes,
okay, I think you might have you said you have done diploma, right? So you might have done a project in diploma also, I guess.
Oh, yes, sir.
What's the project that you did in diploma?
Yeah, it's very simple, sir. That is automation. Home automation.
Home automation.
Yeah.
Like, what did you do in used, or what was the domain which you worked there, like for the project?
Yeah, it's also embedded.
Embedded.
Actually, it is very simple, sir. I have used Arduino. In that, I have used system in embedded C code.
Okay.
I don't know that much coding, so I have taken from. I have gathered the data from Google itself. The sensors I have used is light sensor.
Okay.
And that what is that?
Understood. I got it. Don't worry. I'm from diploma, and I did the same thing. Right. Even I did the same thing. I did a automation project using a microcontroller 8051C, and I did some fire sensor, smoke detection sensor, and IR sensor something, and did the same thing. That's okay. Don't be a small project. You consider it. Okay. Fine. We'll move forward. I'll start to pick some questions from digital. Let's see. Okay. Hello. Relapalli, I'm not able to see your video clearly. Yeah, it's lagging.
1 minute, sir. Actually, I'm from village. Maybe some disturbance from signal. Am I clear, sir?
Yeah, now it's good. You're lagging, but still it's okay. Fine.
Yeah.
Okay. My first question would be, what is a gate?
So actually, gate is the building blocks of the signal, which works on the 0 or 1, sir.
Building block of?
Which gives the output depending on logic.
You said building block of?
Gates are the building block of the digital.
Fine. So what's their operation?
Depending on the inputs, 0, 1, it gives the outputs. And
What do you call that
relay
thing?
also.
What do you call
Sorry,
that
sir?
thing? What do you call that thing? Depending on 0 and 1, what does it do?
It it converts into output what we say. If for AND gate, it will be multiplication is the logic. For OR gate, AND is the logic. Like that, for NOT gate, it is inversion is the logic. But for buffer, there is no logic. Only.
So what can you say a gate as? A building block of digital electronics, and what else can you say? Which performs?
Logic operation.
That's it, right?
Okay.
What is a gate, sir?
It's a logic.
Building block of digital electronics, but it does. What does it do? It performs a
logic.
Yeah. See, what if you are going for basics, you need to be specific. Okay.
Okay.
Okay. What is a flip flop for you? Like, what do you mean by flip flop?
Yeah. Flip flop is a device which stores the data, and it works on the clock input signals. Due to clock signal, it is reliable, sir, because it gives the data, it stores the data depending on the clock signal which we give to the device.
You said that flip flop is a device.
Yeah, like yes, sir. Cell, sir. It is a cell which stores the data in the form of 0 or 1.
Okay.
Mostly use it for memories.
Okay. How do you say that it stores a data?
Like during a pause, it is edge sensitive, sir. During edge sensitive, it stores the data. Due to during native, even after native, what to say? Native edge, it will store the data. It doesn't remove. What is that? Release the data, sir, until the next input. Next clock edge.
So you mean that until the next positive edge, the data will not be left out?
Yes, sir.
Okay, fine. What do you mean? What's the difference between flip flop and a latch?
Yeah, both are same, sir. The only difference is it is edge triggered and it is level triggered. Flip flop is edge triggered and latch is level triggered. But latch doesn't have clock input signal, sir. If you have clock input signal, then it works as enable signal. Like during positive, during active edge, it will give the it will work as like during active condition, it will give the output and it works as transparent. But during negative, it will store the data.
So you can't make a negative edge triggered flip flop. Can you make a negative edge triggered flip flop or not?
Yes, we can.
How would you modify your flip flop to work as a negative edge?
I'm not sure, so I'm not getting.
Okay, fine. Are you using your laptop or mobile?
Mobile, sir. Actually, I'm facing the connectivity issue. That's why.
That's okay. And just draw a flip flop now. Give me a minute.
Yes, yes.
Okay. No, you don't need to worry. I'll draw it on the board here only on the whiteboard. I'll just share it to you. Okay. So, are you able to see the screen?
Yes.
Okay. What is this? Now we'll call this as a flip-flop.
Okay, sir.
Okay.
Okay, sir.
Okay. Now, what are the inputs for this flip-flop? It's a D flip-flop.
Yeah, in one input signal.
Which one?
Yeah, either it will be 1 or 0.
Okay, fine.
And another one is clock signal.
Okay.
And the one is output signal. I mean Q and Q bar.
Q and
Q bar.
okay, fine. Now what is this? Clock.
Clock signals.
Okay, fine. Now I want. Okay, tell me what is this? Like, is it a positive edge triggered flip flop or negative edge triggered flip flop?
It's a positive edge, sir, because
How can
it is.
you
I
say
mean,
that?
the dot is not there. Like
Where? Where is
sorry,
the
sir?
dot? Where is the dot?
Like at
Where
clock,
is it?
the dot. The small circle.
What do you call that small circle?
I mean, it is
Sorry, I'm not able to hear you. Hello.
hello. Hello,
Yeah,
sir. Am I audible?
yeah. Now you're audible. Yeah, continue, Radhapal.
Yes.
How can
Yeah,
you
we can
say this
say.
as a positive edge triggered flip flop?
I forgot the symbol name. Actually, if the dot is there, then we can say negative. If, without that one, we can say positive.
You
Yeah,
mean to
there,
say
sir.
this one?
Yes, sir.
That's called as bubble. Okay,
Okay, sir. Bubble.
bubble. You can just say bubble. If the bubble
Okay,
is there, we can say it as a. Okay, that's good. Okay.
negative. I mean, negative and signal. So,
Okay, okay, fine. Can you make your latch as a level triggered, right? If it is, can you make it as a negative level triggered? If it is a positive level triggered, sorry, latch.
sir, no, sir, because it is not clock signals, right? So it's just in the enable.
Hmm.
We can't do that like a negative edge signal, negative edge and positive edge lines.
Very good. Fine. Okay. What do you mean by slack?
Slack is the difference between the arrival time and receive time and arrival time.
Sorry.
And if arrival time in receive time is what is that? Less than arrival time, it will be set up slack. And if it is
No, I'm generally asking as a slack. What do you mean by slack? I'm generally asking, not with the STA. Not don't go with the STA. Just answer me what is slack.
okay, slack. Between the two signals. Can we say difference between two signals where the chance of losing data?
Can you say slack as a difference between two signals?
Time difference between two signals.
How?
Like if we are going to bus, but bus departures at 7 o'clock. If we are not there, then
no, you are again going with the setup slack.
there at
I'm not asking about the setup slack. You are going to setup slack. I'm not asking about the setup slack. Just define what is slack.
I'm not getting normal.
Fine, that's okay.
Definition.
What do you mean by propagation delay?
The delay from the delay that is occurred by the network. Nets to read the destination from. To read the data from source to destination. It is due to capacitance.
You are again going with the PD. I'm asking general. What do you mean by propagation delay? Okay, I'm asking you a propagation delay of a gate.
Like the time taken to travel. Travel the what is that? Travel the data from source to destination.
What's the source of the gate?
Input.
Okay.
Input
What's
or
the
output.
what's
The
the
time taken to give the output from input.
What's the destination?
Output, sir.
Okay, good. Fine. Now input output is your
Input is our source and output is our destination.
okay, fine. Okay. Now, what do you mean by clock?
Clock is a combination of both positive edge and negative edge. Which will have what is both positive. It is generated by oscillator. It is generated by oscillator. Like for depending on this only all the having.
No, I'm just asking you to define clock. That's it. What is clock? Be simple with the answer. Simple and specific. What is clock?
Clock is generated from the oscillator, which is a combination of both positive and negative time period.
Okay. Then you're saying that the clock is a positive and negative combination signal, right?
Yes, sir.
Then do you provide positive and negative clock signal to a flip-flop?
Like we can provide positive edge and negative edge, but we can't and a label, but we can't provide the.
You just said, right?
No, actually for flip-flop only 0 and 1 will be there.
Yeah, I know that, but the thing is, you said that clock is a positive and negative cycle, right? Something.
Yes, actually I told in only analog. Later it is a combination of 0 and 1.
If you say that 0 and 1 means if you have a clock like I'll just share I'll just share okay, if this is the signal, then if this is plus 5 volt, then this is minus 5 volt, then how can you say this as if this is a 0 line? How can you say this as a 0 and 1 clock? You can say this as a plus 5 and minus 5, right? How do you say this as a 0 and 1 clock?
Above that, above 0 we will be positive, right?
Then what?
Yes, sir.
Okay, as per you, it should be like this. 0 and considering 5 as 1, then it should be 1. As per you, this must be clock. Then what do you call this? What do you call this?
This is the clock, sir. It's combination. That's okay, sir.
Okay, fine. We'll move forward. Okay.
Okay.
What is fan out?
Number of outputs connected. Number of input bits connected to the outputs. Inputs connected to outputs.
Okay. What does that do? What does that define?
Sorry, sir.
What does that do? Means if number of inputs connected to output means if you have a 10 outputs, you connect 10 inputs. That's it, right? So what's the
number? No, sir. number of inputs connected to single output, sir.
So from
That is
one
fan.
output, number of inputs, what you are connecting is a fan out.
Yes, sir.
I can connect 1000, right? From one output, I can connect 1000.
Yeah,
So
that's
my
why
fan
we
out
have
will be 1000.
HFNS. For that, we will set limit. Other than that limit, we have another like splitting and cloning. We have
Okay, I
technology
got that. But the thing is, what do you mean by fan out? You're explaining
The
me,
cell,
but I just need a definition of it. Brief it.
the cell driving the number of outputs, we can say.
Yeah, got it. Okay. What do you mean by mux?
It's a multiplier. It is a multiplier. It gives the output depending on the select lines. The
Okay.
select lines will be the 2 power n, and input will be the 2 power n, and select lines will be n, but output should be 1, sir, for mux.
Mux output should be 1.
Yes, sir.
Okay. Give me an example of mux, like one mux example.
In general, sir.
In general. Explain me a simple mux. Any mux you take, explain it me in simple words. No need of diagram.
Like 2 into 1, like that, sir.
Yeah.
Yeah. Like in 2 into 1 mux, so only 2 inputs are there, but and one select line is there, and one output is there. Then output will be the yes bar. If select line is yes, then yes of that inputs are like if we say a bar, a b, yes bar plus yes bar of a plus yes of b.
Okay. No need of equation. No need of equation. If I have a select line, what does select line do?
It simply selects the input to outputs depending on it simply selects the input to give the outputs. We can say
Simply
connect.
select the input to give the output. Okay.
Yes.
Then how does it select two inputs? Either of them?
Like if if it is 0, then it selects the first one, sir. Because depending on the logic, like a 0 1. If it is 1, it selects the second one, sir.
Okay. So apart from 2:1 mux, how many kind of mux have you explored or have you been known to them?
Yeah, it is 4 into 1 and
4 into 1.
4. Sorry, sir.
2:1 mux. Apart from that, what are the others?
4:1 mux.
4:1 mux.
Yes, sir.
Okay.
Other self lines are 2, like 8:1, 16:1. Up to there only I have explored, sir.
Okay. What happens in the 4:1 mux?
Like here, 2 inputs are there. Depending on the, 2 select lines are there. 4 inputs are there. Depending on the 2 select lines, it selects the inputs, sir.
Fine. Okay. So 4:1 in the name 4:1 mux. What does 4 defines and what does 1 define?
Yeah, 4 is the input. 4 defines the input, sir. 1 defines the output. We do not. Hello.
Yeah, I can hear you. Continue.
Depending on input.
No, I'm not able to hear you. Your network is lagging relatively.
Are you audible now, sir?
Yeah, now it's good. Okay.
Yes. 4 is the input and 1 is the output, sir.
Okay, fine. So if there are 16 inputs, how can you calculate the select lines for 16 input?
Yeah. We can like 2 power n, we'll calculate 2 power n must be 16. Like from there we will set the, we will get the set line, sir. N is the
So
select line.
how can you say 16 or can you get a 16?
Yeah, 2 power 4.
2 power 4 is
16, sir.
okay. So what are the 4?
4 is the select line, sir.
Very good. That's okay. Fine. Let's move somewhere to analog electronics, some basic analog electronics, some MOSFET theory. Can you define the formula for channel creation in enhancement mode MOSFET?
Actually, I didn't cover that CMOS, sir.
Okay.
I'm a bit lagging in CMOS.
Fine. Okay, I'll come the other way. How much is the gate voltage that you are going to give so that there is a channel created in MOSFET? Do you have idea about this?
I think it's 0.7, sir.
Or can you say 0.7?
Actually, it is like a silicon. MOSFET will create on silicon, right, sir?
No, you are not getting there. Fine. You have any idea about difference between the MOSFET and BJT?
BJT is voltage controller. Voltage controller. Hello.
Yeah. Continue.
MOSFET is gate control, sir.
Sorry, you said something very differently between the difference. What is MOSFET and what is BJT? Tell me the difference between these two. If you know, you continue. Otherwise, we'll skip.
Actually, I'm not getting that difference. I have searched in Google, but I'm not getting those.
Fine. What do you mean by clock skew?
Clock skew, the difference between the clock arrival of the arrival of the clock input signal across the chip. So
that you call as a clock skew.
Yes, sir.
Then what do you mean by clock slack? Slack. I mean, what do you mean by a slack? Difference between the slack and skew.
Difference between slack and skew. Yes, the time taken for the time difference between the two clock signal to reach the input of the flip flops, consecutive flip flops we can say. But slack for it is only for one. We can calculate for only one flip flop like that.
Okay. What do you mean by jitter?
It is a slight variation. A slight variation of the signal with respect to ideal signal. We calculate in time.
Fine. We'll move somewhere to PD domain questions. I'll start with them. Okay. What are the inputs for physical design?
For PD, it is gate level netlist, sir, and physical library, logical library, and technology file, and TLGP file, and UPF file if it is a multi-domain or hierarchical design, it is UPF file is required, scan-gen and .sdc, sir. SDC file.
Okay, fine. So, did you do any projects in PD?
Yes, sir.
Explain me about the project.
Yeah, actually, that project have 40 micros. Actually, I have done on 9 metal layers.
Okay.
In that, I have used 70% of core utilization. In that, I have 40 micros. I have done, in placement, in floor plan, I have done. Can I say like steps, sir, or what?
Everything. Or you brief out to what is the project you have done. Just brief out. Don't explain everything. Just brief out.
Yes, sir. I have used 250 megahertz frequency, sir, which is for what is that? 4 picoseconds. Yes, 4 picoseconds, and I have used 9 metal layers, but top metal layers I use it for routing, and below it, power plan, and below one, lower metal layers use it for routing, because in lower metal layers we have, air drop will be high, and I have done I have faced a floating via, what is it? VS violation, VS violation, and floating VS violation, and connectivity missing. PG connectivity. So I have reduced that violations. Then after in power plan, I have done 3 types of power plan. What is a ring? Ring. Another one is mesh. Another one is rail. In placement, I have done. In a placement, I have faced congestion. One is I have faced only 2 congestion. One is routing congestion, and another one is cell density congestion.
Okay.
Yeah, for cell density, I have done soft placement blockages. For routing, I have used routing blockages. In DSC, and I have done timing. I have fixed timing violations also. Then after in CDS, I have here we worked on the timing only, typing like for a better timing, what we say. Yeah, in placement we worked on static time. Not static, setup time violation. Here we have worked on whole time violation, because and in routing we have done I'm not getting that routing part. So.
Fine. Okay. We'll start with something from floor plan. Have you done partitioning and all, or just started directly from APR floor plan?
No, sir. I didn't do any partitions, sir.
Fine. Okay. Then, did you follow any rules or guidelines for macro cell placements?
Yes, sir.
Can you define few rules or?
Yes, sir. First one is the macros should be placed at the boundaries of the core, sir, and pin should be, pin should be facing to the core, center of the core, and offset should be there. If pins are not there, pins are not there adjacent to macros, then we can go for abort placement. If not, if pins are there, we have to go for, we have to give offset value, and we have to make sure notches are not there, and we not there. And the macro should not be at the center, sir, because it will affect the routing. It will make cause the routing congestion. Yes, sir. Yes, sir.
Then, which one did you do, aborted or non-aborted placement?
It's channeled, sir, non-aborted.
No. Fine. Okay. What do you mean by power budgeting?
Sorry, I'm not sure about that.
You did the power plan, right?
Yes, sir.
So what do you mean by power budgeting in that? In power plan, you
might
have
first time. I don't know that power budgeting.
Okay. Have you got any IR drops values in your project?
No, sir, I didn't get any higher values, sir.
IR drop.
No, sir, I didn't get any higher drop values.
Okay, then how did you design your power mesh?
Like, I mean, what do you say? We just learned how to like give the design the power mesh rails and this ones rings only, sir.
Okay.
But
So you don't know about power budgeting or power,
yes, sir.
anything related to IR drops?
Yes, sir.
Okay, fine. Like you said that you worked on 9 metal layers, right?
Yes, sir.
So can you define what each metal layer contained or what each metal layer was destined to operate like employee?
Yes, sir. First, 9 and 8 is used for ring macro. Ring power plants, sir.
You said that you did mesh. You did mesh or you did ring power.
Also, mesh, ring, and rails, sir.
Okay, and all of that be in one design.
Yeah, actually, he taught me like that to learn everything. To learn how to do those
But
also.
what was your project finally? Like you did any individual project or you just learned all type of those? Like you had any one single project done?
No, sir. Actually, we don't. As I am from weekend, weekend.
Hello, I can't hear you. Yeah, continue.
Hello.
Yeah, continue.
That much, sir. That's why I couldn't able. Yes, actually, I couldn't able to use the tool that much, sir, because I am from weekend batch.
Okay. Which
So
was
I
the tool you
did
worked on? Like
I62, sir. Like
Synopsys,
synopsis.
right?
Yes, sir.
Okay. So fine. We'll move to placement stage. Like what does actually placement stage do? What do you work on placement while doing the process of placement?
Yeah, actually, we have. Placing the cells in side rows. Without any violations and without any congestion,
Mm.
and with better timing.
Mm.
And I have done. First we have placed the stand cells. Then after we have legalized the stand cells.
Mm.
Because when we drag pull the stand cells, it will place near to the macros to save the core area. Then after we legalize legalize the stand cells. When we are legalizing the stand cells, the stand cells will sit in the side rows.
Mm.
And then after I have checked for congestion, I have say, then after I have remove the congestion violation. Congestion and that routing violation.
Okay.
Cell density and routing violation. Then after I have done that timing. I have fixed timings by using that bonds multipath.
What do you mean by physical cells?
Yeah, physical cells are used. It is not a part of netlist .v,
Mm.
and it is used for. It is used for the. These are additional cells which is used for the support of the chip. Like those are tap cells, decap cells, and cap cells,
Mm.
and tie high, tie low, spray cells, and boundary
Okay.
cells, filler cells.
Mm. Fine.
Yes, sir.
What do you mean by a boundary cell? What does that do?
Yeah, actually, it it avoids the connectivity between the blocks. If it is hierarchical, then it will provide the avoid the connectivity between blocks and say get what is the power to ground. And as well as while etching process, the boundary cells edges of the chip will damage. If we are using this boundary cells, then if we lose boundary cells, that doesn't affect the functionality of these chips. For that, we will use boundary cells.
Okay. What are tie cells?
Tie cells are used to what we say. If short-term fluctuations of voltage fluctuations are there in chip, then it will lead voltage fluctuations to chip.
Sure about tie cells working?
Tie low. If more gating, more power is what we say.
Fine. I'll give you a scenario.
Okay, sir.
You have some standard cell which has some 2-3 inputs, and out of which 3 inputs are connected. There is one input, and you are getting one input, the output of some other cell or some other macro output is connected to your standard cell's input. Okay, for one of the pins. The thing is, the output keeps on changing from macro, but you need a stabilized input for that, like either high or either low. What will you do now?
Stabilized output. Yeah, yes, like tap cells. It will. What we say? It will give the stabilizer input to the gates. Like like if high current voltage is coming, then zero will give. The tap cells will give 0, which is tie low. If low current is coming, it will give high, I think.
Fine. We'll move this forward. What do you mean by crosstalk? Any idea about crosstalk?
Crosstalk, like noise, right, sir?
Yeah. What do you mean by crosstalk?
Yeah, noise.
Not noise.
Yeah, noise.
Crosstalk completely. Define specifically the crosstalk. If you don't know, we'll skip. Okay.
Am I audible?
Yeah, you're audible. If you don't know, we'll skip. Hello. Hello.
Okay, am I audible? Hello, sir, am I audible?
Yeah, you're audible, but your video is not.
Yes, sir. I will turn off, sir, to just confirm whether it is.
Right. Continue.
Yes, sir. I'm not sure about crosstalk, sir.
You sorry? Come again. I'm not able to hear you.
Like I don't know that crosstalk that much, sir.
Okay. Okay. Have you heard about signal integrity, something like that?
Yes, sir, but I'm not getting. I have heard, but I am not getting.
Fine. Okay.
I'm not getting.
He asked you about metal layers. You didn't answer to that question. What What
Yes,
is
sir.
your first metal you are doing? What is your second metal you are doing?
Sorry, sir.
What does your first metal layer do?
Hello.
What does your second metal layer do? What does your third metal is going to do?
Yeah, actually, M9 and M8 for this rings, sir,
Hmm.
and M7 and M6 for macro rings, sir. Like we have
Macro.
created
Okay.
macro ring also, sir,
Hmm.
and M6 and not 6, M5 and 4 use it for mesh, sir, for overall mesh.
Hmm.
And yeah, I think yes, remaining use it for routing. Uh,
Then where does your clock
yes,
routing happen?
like M5 and M4. Yes, M3 and sorry, sir. Actually, M9 and M8 for this one's ring, sir.
Hmm.
M7 and M6 for this mesh, sir.
Hmm.
And M5 and M4 I use it for CTS, clock routing.
Hmm.
Okay. I'm not getting those.
Okay. Fine. Hmm. What about what do you mean by setup and hold time? Setup time and
Uh,
hold time.
yes, the minimum time required for the clock signal, the input signal must be stable before the positive edge of the, rising edge of the clock, sir.
Hmm.
And the minimum amount of time required to the input signal must be stable after the rising edge of the clock is a hold, sir. Hold, sir.
Okay. So I'll ask you a question. Now you have a setup and hold slack at a time,
Okay.
and you have to deliver your chip to a person, to a vendor in another 15 days,
Okay.
and you can
Okay.
you can resolve the setup slack in 14 days, and you can resolve your
Okay.
hold slack in 15 days. So
Okay.
which one will you resolve, and how will you resolve both of them? Which one will you choose to resolve in both of these?
I think
I'll repeat the question.
setup.
You have 15 days to give your chip to your customer. You have a setup and hold slack, both are present. You need 14 days to resolve your setup slack, and you need 15 days to resolve your hold slack. So which one will you
Okay.
resolve right now? On the 16th day, you need to give your chip. You have 15 days time from today.
I'm not. setup Slack. I think.
You'll try to remove work on setup Slack.
Okay. Sir. Yes.
You
Sir.
said, yeah. Then why do you try to remove work on setup Slack? What's the reason you are looking for a setup Slack to work?
Setup Slack. Can
Okay, fine. I think you're not able to get that. I think we'll end this. Okay. I'll just say some things you have to manage with them. Okay, you are very good at digital. Keep it going. Yeah, you focus somewhere
okay. Sir.
on two basics, like some definitions are very generally asked, like gates, flip flops, everything. You have to work on them. You have to focus on Slack setup, jitter, propagation delay, rise time, fall time, all of these things. Work more on analog
Okay,
theory.
sir.
For sure, they are going to ask, like analog electronics and CMOS. These
Okay.
you are applying for a PD role means they are going to ask a lot about this. For full custom and for
Okay,
PD,
sir.
you need to know analog theory, because if someone asks you to explain an inverter based upon your explanation of inverter, they will be taking you, or based upon how you understand the current flow also, that will be needed, because this is more important for you in the power grid thing, like after flow plan, power planning you'll do, right? While doing the grid or while designing a mesh, this will be come into act. Okay. And you said something about timing of
Okay,
250
sir.
megahertz. If you calculate, it will be
Yes, sir.
4 nanoseconds, not picoseconds. Be specific with the units, okay? 1 by 250 into
Okay,
1 by
sir.
250 mega. Mega means you will have 6, right? 10 power 6.
Yes, sir.
So if it goes up, it becomes 10 power minus 6. And if you take
Yes, sir.
250, it will change. Again, it will become 4 nanoseconds, okay? Be specific that.
Yes,
And
sir.
you have to, you are good at physical design parts, but you have to work a lot on that. Try to get more information about your project, because you are saying that you did ring, you did mesh, everything in one project. That's not possible. Your project needs to have either ring or mesh or the other one, not everything at once. Okay. Get to know about
Okay.
that. And whenever the interviewer asks you about anything, why you change the domain, you have to be specific with your reason. Like I'm saying, like you should be you should give a passionate reason. It should not be like I
Okay,
wanted
sir.
to do because I knew a Verilog or VHDL. I could have taken that question to something else. Then I could have asked, why didn't you go for design verification? Why you came into physical design, right? Because you won't work on Verilog codes or these codes in um, what physical design. Okay, you will work all of them in the RTL side, design and verification. So you be specific with why you chose, and yeah, uh,
Okay.
and don't show yourself as at a loser end, like, or a weaker end. Don't say that I had some family problem that and financial problem, so I didn't choose like that. Don't say that. You try to showcase yourself that I wanted to pursue that, but I was more interested towards I got this opportunity and I wanted to explore this area also, so I explored this and took some time for me to get into PD domain, so I got into PD domain, tell like that. And you have to know
Okay.
about your projects. They are going to ask you about your projects. Everyone will ask you about your projects,
Okay.
either in diploma or these things. Just give some brief about your project. What was your project? What was the domain of the project? What's the aim of the project? What it is going to do, and how you are going to do on that. Okay. And whenever the
Okay.
interviewer gives you a hint, try to grab them. If I'm giving you a hint, like I said, you have a standard cell which is communicating with the macro. You need a proper 0 or proper 1. What will you do? Like that. You have to try to grab those hints. Okay. The interviewer wants you to answer. He doesn't want you to be like, no, don't answer. He wants you to answer. But yeah, you have to grab that thing, okay? And look into crosstalk, signal integrity, routing, CTS, they are going to screw you, okay? These are the questions, and be something familiar with the guidelines of macro cell placement. Like they will ask you about fly line analysis, etc. and all. Be specific with them. Yeah, you can do good. Focus more on analog electronics and revise PD topics daily, because you'll be have to going through this, and some might ask you about the commands for PD also. Okay, so keep focused on that. Focus on more on analog electronics. Try to revise digital electronics also. Apart from that, everything is good. Yeah, whenever you are attending an interview, make sure that you are well lit, and make sure that light is not from behind, because it reflects on the camera, so the interviewer can't sit on the other side, so that light falls on your face, so that it will make your appearance clear to the interviewer. Okay, and always try to keep the camera like this. Don't keep it below. Okay, if you do that, everything is fine. Yeah, be confident about your answering. Don't get panicked or shivered. Even though if it happens, that's for 1 or 2 interviews. Okay, see, you have more opportunities. You have to crack only 1 interview. Okay, you'll have 15 opportunities. If you crack 1 interview, that's enough, because you don't need to crack all 15 to 15. Okay, you need to go into 1 company, right? You can't work in all 15 companies.
Yes.
Right? Yeah, be specific with the answers. Yeah, you're doing good. Try to improve on those topics whichever I have said. Okay. I think this is the feedback from my side. Try to improve on this. You'll get into a good company. Be confident. Okay.
Okay.
Right. You have any questions?
No.
Fine. Okay. And I'll give you one hint. From next time, if the interviewer asks you about you have any questions in the last, you inquire them regarding the role they are taking you.
Okay.
If possible, if the interviewer is friendly, ask him to rate your performance.
Okay.
And third one is ask, if possible, keep it to the least priority. Ask for the growth in the company. What are the roles you are going to work on, which project or area you are going to work. If not project, like what are the nanometer technologies you are going to work, and what growth you can expect from the company. That's it. Try to ask these 3 questions. Okay. Try to get a review first. Try to ask for what role they are hiring you, and try to get the growth expectation from the company for you. Okay, these 3 things you ask means that will give an impact to the interviewer that you are interested in the company. Before attending the interview also, try to know more about the company. Just go to Google, type the name of the company, understood when did it start, and how it has evolved, and what are the areas they are operating. For example, Capgemini are into IT field, Capgemini are into semiconductor field, consulting field, some other fields. So try to know what this company does, and try to just get a brief idea. Just go, make sure that you have 2 minutes of data to speak out if the interviewer asks about what do you know about our company. Okay, this is what few companies would ask. That is why I recommended you. Okay.
Okay.
Fine, Ralapalli. All the best for the interviews. Good luck.
Thank you, sir.
Fine. We'll end the session, I guess.